Hello to all the listeners out there. Welcome to our Hordes Dairyman monthly webinar series. My name is Abby Bauer, and I'm a magazine editor for Hordes Dairyman and the Journal of Nutrient Management. I will serve as the host for today's webinar, which will focus on manure processing technology. Every farm that has livestock has manure and must find a way to manage this sometimes cumbersome but always valuable byproduct. From land application to energy generation and more, manure can now be processed in ways that generations before us likely never imagined. This webinar will focus on some of the manure technology that is being put to use on today's farms. Our sponsor for today's webinar is McClanahan, and we thank them for their support of this program. If you are listening to the presentation live, you have access to a PDF copy of the slides that will be used today. That handout can be found in the handout section of the GoToWebinar control panel. Just click on the link and then you can print or save those slides. Also, if you have any questions for our speaker, please type them into the question section of the control panel and we will answer those following the presentation. Today, we welcome Dr. Rebecca Larson as our webinar presenter. Dr. Larson is an associate professor and extension specialist in the Nelson Institute for Environmental Studies at the University of Wisconsin-Madison. She grew up in Michigan and completed her bachelor's, master's, and PhD in biosystems and agricultural engineering at Michigan State University. The main component of her work focuses on food waste and livestock manure systems, improving sustainability and reducing environmental impact while maintaining profitability. Dr. Larson, welcome to the webinar, and I look forward to hearing from you on your presentation, which is titled, Will Manure Processing Technology Work on My Farm?
All right, thanks very much, Abby. My name is Rebecca Larson, and as Abby mentioned, I'm an associate professor and extension specialist at the University of Wisconsin-Madison. I've been there for about, I want to say 12 or 13 years now. I would say the majority of my work focuses on manure. So I have a lab and I do a lot of presentations and get around the state, and my students lately have been able to guess certain farms based on the smell of their manure. So really always having nice scents and things in the lab and what we're working on. So today I'm going to talk about will manure processing technology work on my farm. I'm going to cover a variety of different processing technologies, some in a little more detail, some a little bigger, and then I'll share with you some resources if you want to look and read about any of the technologies any farther. So I'd like to start out with this picture because I was at a manure expo, and I see a lot of times they have like the classic tractors that people like to look at, and they had a really old manure hauler out there. So this is a old hauler that they used to spread solid manure out there, and it used to be attached to some kind of animals, right? So it was really interesting to see this as something, but it reminded me always to think about, some things haven't really changed in manure, right? We're still taking manure, we're still land applying it, but there are a lot of opportunities to integrate some new technology or some processing on your farm. And, sometimes when we think about it, those can be advantageous. And today we're going to talk about how that might play out, but also that sometimes they're not advantageous, and maybe sticking with the typical system that you might already have might be the best for you in the moment. All right, so I always think about manure systems as this kind of sustainable system, right? We're producing manure, we're maybe processing it, maybe storing it, depending upon our facility, and then trying to get all those nutrients back into the crops to feed the animals, and anything limiting some of these things from then escaping into the environment, right? Because not only does that pose issues for the environment, it also means nutrient losses that we then have to purchase and replace to add to our farm, so that can be costly, right? So a perfect system would be we're keeping it all contained on our fields. We know that that's not achievable, and some losses are actually okay, and the environment can handle it. But the more we can keep on the field, the more we can benefit from those nutrients in our system and not having to find additional nutrients. Processing isn't a step in every manure system. I like to think of manure systems from this collection to land application. Sometimes I'm working with only grass-fed organic systems. They still have a collection and land application. It just kind of occurs all in one step, right, when we're out in pasture. But even a lot of those systems, depending upon where you're located, have some indoor collection and movement. And then you can add processing and then storage. So typically what we're going to talk about today is all of this processing stuff. It's typically going to come before storage. So when you're doing your layout, you're generally going to go from the manure production and collection into the processing and treatment systems, then over to storage. Now that's not every time the way it goes. You might go to some storage before processing in some circumstances, but generally you're going to run through this system. I always call this processing and treatment because processing means you're changing some of the characteristics, but you're not really treating to hit some final end goal. Treatment really means that you're trying to obtain some final goal. And now we are going to talk a little bit about treatment in terms of clean water systems, but all the other parts are processing. We're going to end up with kind of extracting something or removing something, and we'll talk about what our goals are there. But not always is processing ending up with a clean, perfect treated system at the end. And I like to mention that each processing unit has some byproducts to manage, has some operational needs, has some labor. So it's important to think about those in the context of your system as well. Today we're going to cover a little bit on composting, anaerobic digestion, solid liquid separation. So those three we'll get a little in depth in. Sand separation, there's a lot of materials out there. I don't have enough time to get through all of that today. I think our sponsor, McClanahan, has a lot of great information on sand separation. And then there's a lot of other materials. So if you want that kind of information, please follow up after. We're going to talk a little bit about pelleting, pyrolysis, membrane treatment, and treatment to clean water at the end in some slides. But I want you to know we're going to cover a little bit of all of these. And we're going to talk about maybe a little bit about what their benefits are, how to work them into your system, etc. All right, so before we get into those technologies though, I think one of the things when I meet with producers or meet with others, I always know right away if somebody is going to have a pretty successful implementation of a technology system. If I go to see their manure system and they have data on how much manure they haul, how much it costs them every year, what their system looks like, what the pieces are, what pieces work, which pieces they don't like very much, right? So it's really critical that you understand your system. And then you need to make some goal identification, right? So really looking at, I think a common issue I see is people see a really cool technology and then they want to try to, how do I fit this into my system? I recommend going out about it a little bit differently. Whereas what is the problem with your system or what is the improvement you want to make, right? So if it's that I want to reduce my hauling costs, right? That's a good goal, right? And now I need the data to know how much my current hauling costs are and what my options are to reduce that. Also, if you can make the goal more specific, that's even better, right? So if I'm going to do something new, I want to reduce my hauling cost by at least this much money a year before I even look at a technology to know if it's worth it for me to go through all of that work, right? So I think making those goals before you get into a technology makes it a lot easier later to then say, this isn't meeting the goals that I met and this isn't something I want to purchase. Otherwise, you can kind of get lost in the, I think we've all gone through that of purchasing anything that's has a large capital cost to it. There's a lot of other things besides economics. I would say economics are always going to be something you're going to look at. But there's a lot of other drivers that I've seen out there of why people might want to move it and maybe looking at how much phosphorus you need to export if you don't have the land base, or maybe you want to take down your labor needs, or something about your manure collection isn't working with your land application system. So there's a lot of things you might want to think about in your goal identification. But I really think it's important to do this before picking the technology that you're looking for. Again, the data is really important. You can't do any of the analysis that you need to do unless you know some of this, the components of your system. And then, so knowing things like how much manure are you producing annually, you can calculate this just based on the number of animals you have. I use book values all the time. I'm happy to help people do that. Um, then I actually recommend doing that, and then also looking at what are you hauling every year? How many how many tankers did you take out? How long did you run your pumps? However, you're hauling manure, how much of it went out every year? Tracking that over the years is really important. I also think that can just be useful in terms of, well, the book values show this, and I'm like double that, right? So what am I adding to my manure stream that's making the volume so big? So a little bit of understanding what's going on in your system. Costs are hard to differentiate sometimes, but if you can really start to try to separate the labor, the equipment costs, energy, maintenance, any of those components for your manure system, that's great. I know it's a little easier when you have a custom hauler, that you can at least know a little bit about your land application costs because you know what they charge you each year. But trying to separate some of these can really help you select a system that would be advantageous for you. I also think manure characteristics are really important. So a little bit of knowledge on, at a minimum, what your water content or solids content is. There's some systems that just don't work very well for really solid manure or really liquid manure. So it's important to know what your characteristics are, and generally, or how much you have the capacity to fluctuate that, right? So I know I have manure that's a little bit solid, but I do have these other liquid streams. So if I could mix those together. So understanding not just your manure, but where some other byproducts and what their characteristics might be. Some important things, if we're looking at trying to remove certain things, knowing how much nitrogen or phosphorus, it can vary pretty significantly at what's in your manure compared to somebody else's. So really understanding that detail is important. I always think a layout of your manure system, really a whole lot about how you're hauling manure, how you're getting it out to the land. That's a big cost of the actual manure system. So really understanding, if you have a lot of fields that are super far away, understanding all of that distance and hauling cost can really help you to manage that better. Also, nutrient management plans are really, really important here. Understanding, just having a big picture of like, I don't have enough land base each year, or I'm really having trouble getting manure out to these fields, or however it might be working. And then nutrient purchases can also help too, right? If you're purchasing a lot of fertilizers, and you think you might be able to reduce some of that with some improved management, that could certainly affect your end goal there. All right. So after you have all this data, I know it's more exciting to get to what might be useful for me. So the first thing I remind people is that whatever technology you're going to pick either needs to fit within your existing system, or you're going to have to change all those components. I think people don't always often realize, I think a common one was like switching to robots. When people wanted to implement that technology, not realizing there was some things that really changed their manure system in there. And then they had this huge added cost that they didn't think about in terms of handling their manure in a system. So that's just one example. So I just want to remind people, in your manure collection system, there's lots of types of collection systems. You may have to modify it based on whatever technology you select, right? And so I always remind people, sometimes things seem really expensive. There's like vacuum trucks or other things that, oh man, that seems like a big cost. But really renovating concrete and other things, that's usually a bigger setback. But labor, other things might make that difficult for you. But I just want to remind people, your manure collection system is really important. If the technology system needs a different kind of manure, it needs to change the characteristics, you may have to alter that. Now, there's lots of systems where your existing technology may work just fine, but it's just something to verify before you start doing that, so you don't get a surprise added cost within the system. Your manure storage might not be, if you start adding a bunch of liquid to go through a processing system and your manure storage can't handle all of that, that's a concern, right? So make sure that your manure storage system, however you might be handling that, or maybe you don't have manure storage, but it might be required with this type of processing system. So just something to think about. I always say that the collection, the storage, and then your transport system is really important. Um, I've seen before where people switch to a more liquid system on a smaller farm, and then all of their handling system, all of their land application equipment was for solid manure. And then that presents a big cost for them to try to integrate that. So it's just a reminder to think about those three things before you start, as you work through the technologies that they might be key things that kick a few technologies out that then you don't have to research much farther. Okay, so let's get back to the actual processing components and talk a little bit about these. So the first one I want to touch on is composting. I know a lot of people know about composting. They don't think it's like very exciting, but I would say there's lots of cool things happening with composting. And I would say it's a very low cost entry into composting. So you don't have to invest a lot to get into composting. Really, some of the benefits are you end up with a stabilized product, really reduces in odor. You have this huge reduction in volume, right? So maybe around 40% average, I'd say. So you're almost half the volume you started with. So that's really reducing your hauling cost by half, even if you just compost and take to your own fields. You can really get a more consistent fertilizer product. It really destroys weed seeds. It can reduce pathogens. I think there's a whole lot of benefits for composting systems. Now, there is potential to add revenue streams if you want to sell the product. I would say the hardest part about selling composting is that you pretty much have to do the market development on your own. So there's not a lot of markets you can tap into unless you're willing to work with somebody who's already a supplier. And those can be difficult to secure those kinds of uh, connections. But if you can make those, great. But otherwise, I would just say the big thing to think about here is if you want to sell your product, do a little bit of market research on where it might go before you invest in developing the compost system. Composting, the other thing when you're purchasing all of the equipment is that you can do something really low end, right? You can do these kind of windrows, which you see in that bottom picture, the rows there. You can make windrows. They require a lot of space. So you might need a lot of space for certain types of composting, but you might not need a lot of capital. Now, some of the other pictures on the right-hand side, like in-vessel compost systems, they're a lot faster, they're more controlled, they produce a more stable product. If you can really hone in on your control techniques, they might be able to be used a larger amount of the year. Whereas sometimes in the winter, if you've got cold weather, if you're like here in Wisconsin, then you can have some difficulty there running those windrow systems through that cold winter month. So these other systems provide some advantages in that sense, but the capital to install them is a little bit more. So the thing is, the costs for installing compost systems are widely variable depending upon what you're going to do, right? So I would say really low end again is doing some windrows. That's going to be a little bit more labor intensive. So the labor still costs money. So I always try to remind people, they say, oh, there's not really any barrier if I've got the land and I can start composting. I try to remind them that their time does cost something, right? So remember to think that my time's going into this, but it's a really low barrier into getting into there. The markets again are immature, but here's some examples. I know people like to see what are the prices people are putting out there. Generally, you get lower costs if you're selling compost in bulk, and then how you're going to transport it, if you'll deliver it, or if you need people to pick it up. If you want to bag it, that costs another. There's another cost there to installing some kind of bagging system, but you can generally charge more if you've bagged those things. The closer you are to a community that might be needing some of these, the better it might be. We've seen some folks in Wisconsin who, I think there's one facility that's very close to like a city, and they're able to sell all of their manure as compost. I would say that's unusual, but it exists, right? So they found that it was more advantageous to sell their manure and then have to buy their fertilizers as they need them, and that they were actually making money in that sense. So that might not make sense for you. Maybe you can only sell it in bulk, but I still think composting is a great way to process your manure. Again, this only applies if you have solid manure or if you have slurry or liquid manure and are removing some of the solids. So later we'll talk about solid liquid separation. After you've removed the solids, you can go into these composting systems if you want to try to improve the product. You might have to find additional feedstocks to raise the carbon to nitrogen ratio of manure. So that's one other thing to think of. Again, it's a low entry point. You can reduce your hauling cost by almost up to 50%, maybe 40%. You might be able to sell the compost, and you could take tipping fees if you were going to bring in other materials that people are trying to get rid of, like food waste. But that again might require more permitting. It's more work to manage it. I always say if you want to get started, it's easier to, if you want to get in on the low end, to start just with your manure and then add things as you test out and get better at it. Now, again, those in-vessel systems are a little more sophisticated. They provide a little more ability to control the compost, but again, have a higher capital cost. So the next technology I want to talk about is digesters. I'm sure you've seen them out there. There's a lot of them on agricultural facilities in the US now, and lately they've been increasing in number due to some abilities of some costs or some credit markets that allow you to take in some additional funds. Places like California, you can see there's a lot of circles there. They've really been increasing in numbers because they've really implemented some policies in which you can get grant dollars in terms of putting in digesters with the intended benefit of reducing methane emissions that lead to climate change. So they've really put a lot of money into their system in terms of trying to develop that. But you'll see in Wisconsin, we have a decent amount of digesters, all on a smaller scale. Our farms aren't quite as large as what you see out there, but you can find them all across the country. If you ever want more information on digesters, EPA AgStar is a great resource. They have all of the projects listed, so you can go and find who has one if you really want to talk to somebody about them. There's a great resource there. So benefits of digestion, right? You can reduce methane emissions. There's not only is that an environmental benefit in that we're reducing the impact of climate change, but that has a monetary benefit these days. So we're seeing a lot of ability to recover costs by reducing those emissions. And I'll talk about those in a second. And so I think moving forward, there's going to be some growth in this area. I doubt that we're going to see less drivers for some of the environmental benefits. Not only are you going to be able to improve it, but you might be able to monetize some of those as well. So these two types of digesters are probably the most common you're going to see. On the top one is the completely mixed system, and on the bottom is a mixed plug flow. There's a lot of different types of digesters out there, but these are maybe the most common that you're going to find in cold climates where we have winters. So you can run slurry or liquid manure through here. They're operated continually, so you feed them every day. You collect the gas. You can use that gas for a variety of things. Composting is scalable, the first technology I talked about. The only thing is, as you get larger and larger, you need a really big land base or bigger and bigger in-vessel systems. Digesters are very scalable, but the small scale digesters have a really difficult time in terms of economics. So I'll talk a little bit about what are some of the economic drivers right now. But small scale digesters have had tendency just to the economics of scale, that there's some things of how you use the gas. Generally, that's the big one that becomes difficult to pay for if you can't spread it over a large number of animals over a larger system. I did want to mention that there is some dry digesters out there. You can implement these if you want to, if you had dry manure. So the other systems are more for liquid or slurry. If you wanted to implement a dry digester, which kind of acts as a batch system where you put the solids in and take them out, that's very possible. Again, these systems aren't as common in the US. They're very common overseas in Germany and other things. We do have, this one is up at UW Oshkosh. You could mix other things in there. So if you have solid manure, I just wanted to mention that doesn't prevent people from moving to digestion systems. It's just more uncommon because most people handling solid manure at a small scale, so it would be difficult to run those economically. But you could take in other feedstocks and other things to mix with that. All right, so I wanted to mention before I would say maybe 5 years ago, maybe 6 years ago, almost everybody was using the biogas. So we have the digester, the manure goes in, microorganisms degrade, produce biogas, which contains methane. Everybody was using that to either flare, like a direct burn or a flare situation, or go to electricity generation. So they would generate some electricity through a combined heat and power system. These are expensive to run. There's some contaminants in biogas like hydrogen sulfide that make them corrode really easily, degrade really quickly. And so they've converted now a lot to moving towards renewable CNG. But these systems they still function. The problem is in a decade or two ago, you were able to get a contract rate from a utility for about 10 cents a kilowatt hour, which is about 8 to 10 cents, I would say, is about the break even point of running a digestion system with an electricity and power generation. And so the high cost of that, once those contracts were not available anymore and the policies kind of shifted, and then it was really tough to make these systems work, right? So what we're seeing now more commonly is that people are scrubbing the gas, removing the contaminants, removing the CO2, taking that gas and injecting it into the pipeline. And the idea there is that now somebody else around the country can then take that gas out of the pipeline and use it in a more renewable manner, right? Compared to natural gas that we're obtaining from other sources, from non-renewable sources. So why are we doing this? Well, economics are the driver right now. And so I'd say almost all new projects are implementing this. A lot of projects that used to have electricity generation are shifting to this. I saw on AgStar the national numbers. It's a huge growth in this sector. And that's driven by two primary things. One is the renewable identification number credits from US EPA's program. And so you're allowed to then, as you produce this new gas that gets injected into the pipeline, you're getting some credits for this system, in terms of financial credits from other users who have to buy these credits because they have non-renewable fuels that they're using. And so they're purchasing these credits to offset some of those. The other credits are coming from the low carbon fuel standard, which is a policy that was developed out of California that some others have now joined, that also does the same thing, right? You get as you produce the gas, you identify how much of it, you get identifiers, you get the credits as you put it into the pipeline, and then you sell those to other people, and you're able to get financial support from both of those programs. So that's really driving the benefits in those areas. So I would say digesters have all these great things. So if you want to implement a digester, they have wonderful environmental benefits. They have wonderful operational things, and I'll talk about those in a second. But the economics are really the part that has always been struggling. So I would say, a while ago, Brian Langhoff, who runs the UW Oshkosh biogas system, he used to run the Rosendale digester, and he was even talking about, and I think this was a common story I heard from most people, when you're running with the genset and producing electricity, you need about 10 cents a kilowatt hour to even kind of break even, right? So they weren't making a lot of money. Now what we see is, if you're going to add the part where you're cleaning and injecting the gas, the benefits are much higher. Now, at what scale does the payback start to happen? It's hard to pinpoint exactly, depending upon which company and technology you go through, but the animal units required are, a lot of the companies that were doing this were looking for large farms with a few thousand animals. So I would say at the smaller scale, you are still economically limited in terms of making a profit from a digester. Again, digesters are great in that they have pathogen reduction, they reduce odors, they provide antibiotic degradation, although the antibiotic degradation from composting is better. They both, composting and digesters, reduce pathogens and odors. There's a really big benefit in the greenhouse gas reductions from these systems. That's where a lot of these monetary benefits are coming from. So when we're talking about these renewable fuel credits, they're assigning these credits based on this ability to reduce emissions from the manure. And so that's really important because it guides all of that. There's at the Midwest Manure Summit, we'll talk about this, but there's been talks all around if you want to get more into the importance of how you structure these credits and how you structure your system. But generally, that reduction in greenhouse gas emissions is what's driving a lot of the monetary policy. The other thing, each of these systems may have some drawbacks. So I would say in composting, it's that there's more labor and you need a lot of land base. If you in a digester, you're going to mineralize all of the nitrogen. So in one way, that's good in that you're increasing the availability of nitrogen once you land apply it. But then you have increased losses if you're not going to add management steps. And so that's been something that's been coming up a lot. I know some reporters in California were talking about it after they've had a lot of digesters. I know down in North Carolina it was becoming an issue as well because they're seeing more ammonia emissions. And that's not a positive thing, particularly because you want that to go on your crops. What I'll say is there's always some downsides. You can manage those ammonia emissions by doing some proper things and some management practices in storage and land application that can make it so you're not losing as much ammonia. And I'll show you some, we have lots of details out there on all of these things and fact sheets and other things if you want to read about one particular area. Okay, so composting, good. Digesters are great. Compost you can get into at a low cost. Digesters for certain scales are still pretty tough to get into and make financially viable. I do think there's more money going into this based on some new federal things. I don't know all the outcomes of that yet, but those are coming along as well. So now I'm going to talk about solid liquid separation. I think this is a technology that is probably going to be combined with almost all technologies that you implement on a farm in terms of manure processing. So there's a lot of different types of solid liquid separation systems. I always advocate that this is maybe the first one you should look at. Particularly if you're running slurry or liquid manure, that you might want to take a look at a separator. It can achieve a lot of the things that the other technologies might be able to achieve, and generally has a lower price point for entry. Solid liquid separation in general, you're taking manure and you're separating it into more than one product. So in the most basic, you're going through a separator and you have the manure goes in and you get a solid and a liquid coming out at the other end. Now you can run lots of separators in sequence and series and remove even more things from the liquids or squeeze out more liquids from the solids. So there's a whole lot of different types of systems that are available out there. I think some of the most common ones that you may have seen are a screw press and a centrifuge. I'll say a screw press, the equipment itself for each piece of equipment, maybe it'll run you a little around 100 grand, somewhere around there. It's really, the price has been varying quite a bit lately. Centrifuge or something maybe 5 times that, you're talking $500,000 to introduce a centrifuge. I'd say a screw press in general is going to remove less solids and constituents than a centrifuge. A screw press is generally easier to operate and lower costs. So there's a little trade-off there, right? The only way you're going to know which one is better for your system is really running the numbers and looking back at the goals you identified. So for the price point might be higher for a centrifuge, but in a minute I'm going to show you some data on performance that might make you realize that in some circumstances the higher capital cost may be worth it. There's tons of different types of things. There's rotating drums that can remove solids from more liquid manure. There's roller presses where you can, and all kinds of presses where you're squeezing out more liquids. There's inclined screens where you're removing really fine particles. These are only a few. These are the ones I commonly see, but there's a lot more available. So don't think you have to stick with a screw press. That's the only one you've seen. You can talk to these separation companies. They have a lot of different equipment available. Each type of separator has a different influent manure characteristic that it can handle, and then it produces different kinds of products. So it's really important, again, to think about what your goals are, and understanding that they all work a little bit differently. But there's a lot of technologies out there in terms of separation systems. These are all mechanical systems. You can also put in separation systems that are a little less efficient, that are settling systems, but I'm going to today focus mostly on these more technology implementations. So efficiency is really important, right? So when I talk about efficiency, I talk about it in two ways. One is something that we call the separation index, and that's something we abbreviate that with SI, and you'll see that data is on the right-hand side here. And separation index is how much of something, you can think of it, I move into the solid product. So really what I'm looking at when I'm talking separation index is a computation to tell me how much I pulled into a solid product. So if what you're going for is you're trying to remove as much as you can of something, say I really want a lot of phosphorus out of my liquid manure, then what you would really want to think about is the separation index of how much I'm pulling out. Now, there's also something called a removal efficiency. The removal efficiency is calculated a little bit different, and that's trying to talk about how pure the liquid part becomes, right? So as I improve my removal efficiency, the liquid becomes cleaner and cleaner, right? So if your goal is to get a cleaner liquid at the end, even to clean water, you would want to talk about removal efficiency. If your goal is to extract things into this solid component, you might want to talk about separation index. These are important not because you need to calculate them, but if the company you're going to doesn't know the difference or isn't talking about them, that's a big concern, right? I would never pick a piece of equipment where the company couldn't tell me what the separation efficiencies are, right? So that's really important to you. When we looked at a lot of farms out there, we ran for 2 years, just collecting data from, 9 or 10 farms, just looking at the different types of separation that they had and how well it was performing. And then there's in Europe where they have more technologies already implemented, there was a study we also compared this to, coming out of that end. And what we found is the separation efficiency varies pretty significantly. You'll see at the bottom there is TS. I would say a lot of separation systems can remove total solids. But where you start to see a lot of differences is when they start removing nitrogen and phosphorus. And I would say a lot of people are trying to remove those. If your goal is just removing solids, well, maybe all of the systems are generally might be good enough for you. But if your goal is trying to achieve some kind of phosphorus removal or nitrogen removal, then it's going to vary significantly based on the technology that you purchase. And I would say one thing we were noticing is we can really break up efficiencies into what we call low and high efficiency. And what the data kind of suggests to us is if you're in low efficiency, which almost all like screw press separators are, you're not really achieving a phosphorus or a nitrogen removal rate that's going to really help you manage that much. But again, is that specific to your farm? No. So running the numbers and understanding, if I have manure, how much phosphorus would I need to remove to allow me to change the management and save me money, right? Or how much clean water do I need to produce with this? Essentially, those are separation systems with a lot of them in order, a lot of them in series. How much of that would I have to remove to really make financial sense? So there's a lot of numbers up here. The most important thing is when you look at your own system, understand what your goal is. If my goal is to remove phosphorus because I don't have enough land base, well, then it's really important at that point to start thinking about which separation systems are capable of removing that amount of phosphorus. What I also want to mention is, as we actually looked at systems and implemented them, solid liquid separation was also, in some cases better than reducing the CO2 equivalent or the emissions that contribute to global warming than digesters. So sometimes you can achieve these things. I'm hoping that we'll be able to influence the monetary benefits to stretch beyond just digesters, and that we'll start seeing some of growth in these other areas. In California, they've certainly started providing funds to implement some of these things. beyond digesters, some technologies, because of their potential to improve environmental outcomes. I would say solid liquid separation is also really great, not just in the terms of the environmental components, but it really divides manure up and it gives you some great management options. Solid liquid separation is also probably going to be needed before a lot of processing technologies that I'm going to talk about in a minute. A lot of times you're going to need to do more processing in order for the liquid manure to be treated further. So you're going to have to use a lot of the solid liquid separation systems ahead of time to purify, to really enhance that removal efficiency, so that liquid manure has a lot of things removed from it that would impact further treatment systems. Okay, a few other things I want to talk about. So a while ago, I would have said struvite recovery would be a tough thing to do in terms of manure processing. But then I saw a system out of Washington in which they actually have a system for manure that they've been running, recovering about 30% of total phosphorus on average. And you can see what the recovered struvite looks like there. Again, the capital cost can be significant, so $75 to $125 per cow, and then a pretty significant operating cost each year. But if you really have land issues in which you have too much phosphorus, this is a recovered product that can be marketed and sold. And they even had data on how it performed as you land applied it and use it as a fertilizer. So I think that's one area where we're seeing struvite recovery. This is something they commonly do with wastewater, but I would say wastewater technologies have had some problems operating in manure. And this is a technology that might be viable moving forward. Pyrolysis systems, this is what is used to make biochar. I don't know if people have heard of that before. Maybe more commonly would have heard of biochar and not pyrolysis. But pyrolysis is the system in which produces the biochar. The reason I bring this up when we're talking about manure is there's a lot of interest in taking manure solids. So either you have solid manure or you're separating solids, and then using that, going through a pyrolysis system to produce biochar. One of the benefits of that is that you're really reducing the volume in a huge way. And then you're really densifying the phosphorus. Unfortunately, you are losing some nitrogen in this processing system, but I think we're going to see a lot of development here. There are commercial scale systems available to put on farm, but I would say since I haven't seen any really up and running in a full scale system, the costs are difficult to understand. I can see you can definitely get the capital costs of what that's going to be, but it's unsure of what the operating costs and how that's going to function at this time. But I'm seeing a lot of movement in this area. And really the goal here is that you're taking the solids, densifying them, and maybe producing a product that has a higher value in terms of resale. Okay, pelleting. This is where you might take manure solids and compact it and put it in again, you're densifying and putting it in a format that's a little easier for transport and sale. Reduce odors. The thing of this system, I would say, is it's viable. People have put it in, but the systems I have seen that have been installed are on extremely large farms. So that the cost of these, the capital cost of the currently available scales is so high that it would be a really, really large farm that would be able to implement this type of facility. And still the cost is high. So I would say a lot of times the places we've seen these going in is a place where they are really constricted on nutrient application to their fields. And so pelleting is an option. I think there is a big possibility that the companies, like many other technologies we've seen in manure, that they work it out for really large farms, and then slowly but surely it can be more scalable to smaller farms. But I would say a lot at this moment of the last data that I have checked and discussions I have had, this type of pelleting and granulation has really been cost effective only at large farms. I would say one of the most interesting things to me is what I'm calling treating manure to produce clean water. So this is a series of separation and treatment systems that go together that they combine to produce clean water. I would say in these types of systems, manure is treated to water quality standards that you can either discharge, which takes some permitting and some work, but can be done, or can be used for animal drinking water. So you can reduce hauling costs because about maybe around average 60% of the volume is now clean water. But there's a lot of byproducts to manage in this system, right? So you go through an initial, maybe multiple separators, so you have solid products. Then maybe you go through ultrafiltration and you have a concentrate that comes off of that, a reverse osmosis, a concentrate off of that. So you have some new products. But the great thing is if you can manage those products all have different nutrient levels and ratios, so you can manage them to be much more effective out in your fields. And again, these systems are known to reduce greenhouse gas emissions. I know some of the installers are trying to get them as being recognized as technologies that could have some benefit monetarily, so some economic benefit as we see more growth in the ability to get credits for certain types of things. I think these are really interesting. I think the capital costs are coming down quite a bit. I would say for a more basic system, you might be able to get it on the lower end. You can see the capital costs are really big there because as the common processing steps I've laid out in here, from separator, ultrafiltration to reverse osmosis, those you can add more steps, you can remove steps. The really costly end of this starts when you're trying to, you can put in something to remove ammonia. So you're actually capturing and making a, you can do it in a variety of ways. Some of them are making a liquid product, some others. So there's ways to actually get an ammonia fertilizer that you can sell. Some people are selling that on an organic market and making some money from there. And so actually these costs have come down quite a bit and aren't, when you do the equivalent of dollars per gallon of manure, I mean, some of them were in the 3 to 4 cent range or something in that area. So I would say these are becoming much more cost effective. Again, still need kind of a certain size system. On a really small scale system, these might not yet be economically viable. Okay, I just want to say a few things. I know I'm coming to the end. I want to leave some time for questions. But after working in manure forever, looking at surveys, looking about what's going on, the one thing I want to remind people is a lot of times we try to talk about things as, oh, this is a small farm, large farm, permitted. Really, the critical thing is to look at the practices you implement at each scale. So for example, we were modeling some greenhouse gas emissions from different farms, and when you're actually looking at the survey data of the practices people implement at these different scales, it has really, you could be a large farm having less impact than a permitted farm, or you could be having higher. It's all based on the management practices that you implement. So I like to think about that when you're thinking about the system you're installing, right? That's the same concept. It really depends upon these individual decisions you're making. I'm going to skip some of that. The last thing I want to say is what I put out there today, what we've been talking about, is ways to look at these technology implementations from the point of view of a producer, right? So you're looking at what's the cost, what's the potential monetary benefits, what are my environmental benefits, different things that from a perspective of a producer. There's other things that we're trying to look at in terms of looking at it on a larger scale, for example, maybe a watershed or a state or a region, and how these kinds of technologies can help us to improve maybe certain goals, whether they be environmental goals or economic goals, and then how policies and other things can help influence that, right? We're seeing that with the digesters already, that policy of trying to provide those credits can really help drive installations. And so when we're trying to look at some of these things, we're using optimization models to look at maybe a certain area and look at what some of the issues might be, and then how policies might be able to improve it. So as I let this giant computer run all these scenarios, I start looking and seeing that if we can add a certain policy where there's a price point per pound of phosphorus, a lot of those technologies that I mentioned start being cost effective at that time. So there's credits available now for digester and the biogas area. I think in the future we'll start to see some more credits. There's been some credits of dollars per pound of phosphorus trialed around the US. I think we'll start to see some more of that. And then that will help some of these technologies move to a more financially viable situation for a producer. And so really what these models are helping us do is look at what types of technologies are really close to break even or are really far away, right? So I would say before, when I looked at struvite, the models would tell me, no, we're not even getting close to producing struvite at a point that I could sell it, that would make the technology viable for me. But now that there's some new systems and the costs have come down, we're getting closer and closer. And I think some of the things, like the liquefied biomethane, we already see that this gap was small, and then some additional incentives came along, and that really pushed it that way. So we're seeing that some of our results here are leading to that. And so we're modeling more and more of those to not only help producers decide, but help policymakers maybe make decisions that could help those to be implemented. So I want to say I touched on a whole variety of things today. I know the key thing is just understanding your system, figuring out what you want to do, then selecting the technology that will hit that goal. I'll say we have a lot of fact sheets, just so many from the Sustainable Dairy series. There's maybe 15 fact sheets on a whole variety of topics. There's a virtual farm, and we just finished a whole series on manure processing. So going along with today's theme, at the learning store, .extension.wis.edu, if the links don't work in your individual downloaded PDF, you can just go to the learning store, agriculture, animals, manure, and you can read in more detail about almost all of the technologies that I touched on today, and see a little bit more, look at a little bit of the cost information. There's a little more detail on all of those provided within there. And then there's a list of other experts such as myself who also help develop them that can answer some more specific questions if you have them. So I want to thank you for your time. I hope I didn't run too long, Abby, and I'm going to hand it back over to you.
Thank you, Dr. Larson. Everything is great. And definitely thank you for that presentation. I know that all of this manure processing technology can be, like you said, it can be a huge investment. It can be confusing. So really appreciate the way you broke down several of the options that are available and gave an honest opinion about some of the pros and cons that people might run into. So really thank you for that. Also want to thank McClanahan for their sponsorship of this webinar. We really appreciate their support of our program. And if you want to learn more about their company and their product offerings, please look for them online and check out more information about them there. I want to invite all of you to our future webinars. If you want to put that on the screen, Becky. Our next webinar will come up in November on the 14th. And during that presentation, we will have a pair of speakers, Mike Hutchins and Mike Rankin. We'll be talking about the forage and feed outlook, what's going on with the current situation, and then what we can expect or what they predict will be the situation for 2023. And then in December, we'll go back to the basics, and Dr. Joe Dalton from the University of Idaho will be talking about semen handling and tank management. So if either of those topics are interesting to you, we hope that you'll make plans to join us. I want to remind everyone that you can ask some questions now of our presenter. Just type that in the questions section of the control panel. Dr. Larson, I do have a few questions that came in, so I will start asking them now. If you want to click forward one more slide, and then that would be perfect. So first question here, I think the one I'll start with here is, if someone wants to look into manure processing and technologies, who would you recommend as part of their team of maybe consultants that they should work with before they dig too deep into this process?
Yeah, that's a great question. So if you know a little bit of the area, so there's a lot of technology providers, but I would say there's also this level above that I've been seeing lately of so you can use an engineering firm, or you can there's a few specialized groups that are doing just manure processing systems. They might do some other things as part of their business, but they've been designing manure systems, and so they'll work with all the different technology providers. The nice thing about that is they're not necessarily trying to sell you on one versus the other, and they'll give you a little bit more information as to what they've seen and the experience they've had with different types of technologies. And then the other thing is trying to put the things in order and design them in a system. So there's been some really interesting things done on that. There's a few groups out of Wisconsin that have been working on that. I think a few others in the region, but I've seen some really great, like they've moved a lot to these indoor processing buildings, and they've designed and put the pieces in based on what the producers have been wanting there. So that's what a great place I would recommend to start. Depending upon what's going on, sometimes they're quite busy, but I think if you can be patient with them, they'll really help you design a system that might achieve the goals you're looking for.
Thank you. That is great advice. Next question here. Someone's wondering if there'll ever be a way that we can quantify how much greenhouse gas emissions are coming from dairy farms rather than just modeling and our estimates. And what do you think is the best estimate of current dairy farm greenhouse gas emissions? Any comments there?
Yeah, so I think we have measured lots of different emissions from actual farms. And then we take that data and put it into a model to understand a little bit more all of the pieces. I would say I'm always working on trying to get the federal funders to support bigger measurement tools that maybe we could develop, that you could put on your own farm. But for now, I think the estimates are decent. The ones that they're using for predictive purposes, what I saw of the background of that are working pretty well, depending upon which group you're talking about. So the ones in which they're supporting the funds out of California, I think those models look pretty great, have used real data to develop them. We've developed, my own research group has developed a lot of models. That Penn State website that we did for the Great Lakes region has a lot of information there. All of that data we combined from models, but using the data that I gathered around Wisconsin for greenhouse gas emissions. So I would say there's a lot of things there. The tough thing is, if you're trying to do something particular with it, it really takes some expertise to put the data together. And so if you're trying to do something specific, feel free to send me an email and I'm happy to help. But otherwise, we try to decide particular farm data. Gathering on-farm data would be such a huge expense for any farm. It would never be worth it at this point with the technology we have available today. So the models enable us to not gather data from everywhere and then make reasonable assumptions to then give data that we think might be flexible. And I will say I totally understand that sometimes the models might not be understanding the complexity or the specific circumstances, but we try to improve those based upon what the goals are. So I think that the modeling is actually looking pretty good in terms of when they even try to take some of the models and then justify that by actually measuring a farm and making sure the model was representative. So I hope in that long explanation I got something out there. But that whole sustainable dairy series we did of fact sheets and the website, it was all about those greenhouse gas measurements and doing the predictive components. I do think in terms of the dairy side, I know that there were some tools that were available from the some of the national dairy group. For some reason, my brain is not working right now to remember the name, but they have now decided to redevelop that because there were some issues there. So I think the new system that they'll be coming out with soon will be much more representative in terms of that. And then there's some others for organic or other people that might be wanting to use them.
Very good. Thank you for that explanation. The next question is someone who is looking beyond North America and wondering if you have expertise in this area or what your experiences are, but wondering what technologies might be most suitable for dairy producers in third world countries. A more specific example here is a commercial sized dairy in Southern Africa milking 400 or more cows. What technologies might they be able to implement in a climate and an environment like that?
Yeah, that's great. So I actually worked in Bolivia and some in China and some in Africa. And I would say in Africa, a lot of the technologies in terms of greenhouse gas greenhouse gas mitigation and energy production. So we actually did small scale digesters there, and they were really successful because the gas can be used in a variety of ways. One thing I didn't mention today, because I knew I was going to run out of time, is you can use so we would run digesters in Africa to produce energy, and then we would actually go right to chilling. So there's a way to do chilling with some old technology that they use for natural gas absorption chillers. And so a lot of times what I found in like Africa was that they didn't need heating capacity, and then electricity to then produce cooling was really losing a lot of efficiency. So some of the recommendations there were to produce, go right to chilling, either if that's for chilling milk or doing some other, or, chilling in other ways. A lot of people at smaller scale were using that chilling to run, little side businesses where they would be able to keep things cold. So that was really successful there. I would also say the separation technologies are really useful anywhere. And in some of the African countries I worked in, where fertilizers are really hard to come by, or either you can't get them or the cost is so extreme, that it was able to make products more viable for land application in those areas, just depending upon the kind of the cropping systems can be very different. So that was more viable there, and that turned out to be very successful in terms of supporting that crop growth. But if you have specific questions about a certain area, please feel free to shoot me an email. I'd be happy to talk about those in more depth.
Yeah, an interesting experience that you had there. When you say small scale digesters, what approximately would be a herd size that would qualify as a small scale digester?
I'm sorry I didn't make that more clear. That's a good question. Generally, I would say anything pretty small is maybe 500 or less for a digester. The one that I showed that was at the UW Oshkosh farm that's actually maintaining okay is about on a 200 or 250 cow herd. I would say in Wisconsin, the majority of them are on 1,000 or larger, but there's a few that have been installed in the 800, 900 range, maybe in there. But I would say anything under 700 cows, that's not so usual. That becomes more difficult financially to make that work.
Mm-hmm. Yes, that makes sense. We had a comment here. It said that this was a very interesting and insightful presentation. So thank you, Dr. Larson, for that. I certainly agree. And I think too, for our listeners, and we have people from all over the world and all different occupations and ages, but I certainly think that this is an area where there's growing potential, and hopefully there are more young people that want kind of follow in your footsteps and can pursue this area of manure management and utilizing this byproduct in unique ways. So really thank you for sharing your experiences and insight with us today.
Yeah, that's great. Thanks for having me. And I hopefully touched on something that was new to anybody that watched. And if you have follow-up questions, I know it's hard to get super in depth, and most people's questions are, so feel free to reach out. Thanks so much for having me.
Yeah, so once again, thank you to Dr. Larson from the University of Wisconsin-Madison for serving as our presenter today. Again, if you are interested in any of our upcoming webinars, you can see them on the screen. In November, we'll be talking about feed and forages and the year ahead. And then in December, we'll have a topic in reproduction with focus on semen handling and tank management. And then once again, I would like to thank McClanahan for their support of this webinar. We really appreciate them helping us provide this opportunity for all of you out there listening today. And then as always, we want to thank you for taking time to tune in to today's show. We hope that you will join us again on a future webinar. Until next time, goodbye from all of us here, our team at Hordes Dairymen. We hope that you all have a wonderful rest of the month. And again, hopefully we will see you on a future program.